Hello everyone, Aaron here, and welcome back to Leetcode. Today we are doing the counting bits problem. I'm on holiday at the moment, so this one's actually pre-recorded, but I'm sure I'll be back pretty soon. Given an integer n, return an array aunts of length n plus 1 such that each I, between 0 and n inclusive, aunts I is the number of ones in the binary representation of I. Okay. So for example, for n equals 2, the binary representation is 1, 0. So we want to do... there's 0 ones in 0, there's 1 1 in 1, and there's 2 ones in 2. Sorry, there's 1 1 in 2. Yeah, that makes sense. I'm just trying to work out what the pattern is here. So, trivia time. This counting the number of bits in a binary representation of I is often a CPU instruction called pop count, and it'll tell you how many bits are 1 in this particular integer. Now, here, there must be a pattern. The only one with 0, 1 bits is 0. Then there's going to be 1, 1, 2, 1, 2, 2, 3. Hang on, let's write this pattern down. I am 0, 1, 1, 2, 1, 2, 2, 3, 1, because now, so that was 5, 6, 7, 8, 9, 10 is going to be 1, 0, 1, 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 2 again. This goes up to 3. Then this rolls over to 2 again. 3 again. 3 again. 4, and we're back to 1 again after that. So what's the pattern? We have, well, 0 is the easy case. Then we have 1. Then we have 1, 2. Then we have 1, 2, 2, 3. No, 1. Yeah, there's something happening here. There's some rolling pattern occurring. So I expect this one to be 1, 2, 2, 3, 2, 3, 3, 4. See, what do I then expect the pattern to be? I expect it'll drop back down to... yeah, because at the moment we're at that spot. So then this is going to roll around to that. So that's 2, 3, 3, 4, 3, 4, 4, 5. Aha. So it's 1, 2, 2, 3, 2, 3, 3, 4, 2, 3, 3, 4, 3, 4, 4, 5. Right. So there is a pattern here. So for the fifth, so for the ones that are of length 5, bit length 5, this is the pattern. If L equals 0, yield 0, return. Then what we want to do is for in range 1L, so 1, 2, 3, yeah, sorry, 1, 2, hang on, why did this pattern do this? 1, 2, 2, 3, 2, 3, 3, 4. Why didn't that go immediately to 3, 4, 4, 5? It should have, shouldn't it? Yeah, I think it should have. No, it shouldn't have. I'm getting myself confused here. So we were at 1, 2, 2, 3, 2, 3, 3, 4, 2, 3, 2, 2, 3, which is 1, 2, 2, 3. Ah! Okay, I'm sure the way you're meant to do this is just count the bits. But I'm more interested in discovering what this pattern is. So if it's 1, I just generate a 1. If it's 2, I generate a 1, 2. If it's 3, oh, I know what it is. So let's think about this pattern again with the actual binary representation. If I have this, what I want to do is I want to generate all of them for L minus 1. So if this is the 5 length bit, I want to generate all of them for the 4 length bit. And then add 1 to the result of each of them. Yeah, so if I'm doing the for B in self.change. Yeah, so if I'm doing, well, let's do the zero length. That's 0. Let's do the 1 bit length. That's going to be yielding the 0. And then for that 0, I want to also do the 1. And then if I want to do the 2, I'm going to yield the 0 and the 1. And then I'm going to do, for each of the 0 and the 1, ooh, no, that's not quite right. There's a slightly different case here. If L is equal to 1, 0 is mucking this up slightly. Slightly weird. Let's not deal with the 0 case, because a bit length of 0 is kind of weird. So hang on, what do I get so far? Return list self.gen bit sequence of n. I'm expecting I'm missing a leading 0. No, I'm missing quite a bit. Maybe I need to yield the 0 as well. Now I'm going too far. That's kind of strange, but it's close. So I'm doing everything up to 2. The bit sequence is here. Hang on, let me just unravel some of that. So here I'm going to yield 0, yield 1. What was the other case? 5. So I went way off the rails here and added a whole lot of extra stuff. So maybe I'm just doing one too many here. And I want to return list self.gen bit sequence of n-1. Now I'm one short. And I'm still way too long on that one. Oh, oh, I know what it is. I'm doing all sequences up to bit length, blah, which is not right. So, I see. I need to import itertools. itertools.take. Oops. And I think it's going to be n of them. And I don't need to generate the whole. Well, it doesn't matter because I'm not going to actually compute the later things. It's a little bit wasteful actually, but oh, they don't have a take. Okay, I thought they did. Well, let's do that ourselves. We have an iterable that we want to take the first n elements of. For blah in range n, yield next iterable. Oops, that's not how you do that. Anyway, that's fine. And I don't want to take n, I want to take n plus 1, because there's 3 digits between 0 and 2 inclusive, so that's what's going wrong there. Perfect. Okay, I got myself a bit tied up in knots between bit length and length. I made a real pig's ear of this. This is an easy problem? This is an easy problem? It probably is if you just count bits. So, very quickly, what you want to do is, if all you want to do is count bits, what you need to do is you need to do while n is greater than 0, count is equal to 0. While n is greater than 0, count plus equals n mod 2. N equals n integer division 2 return count. That is how you count the bits in a number. So if it is 2, for example, it's a 1, 0 in binary. So 2 mod 2 is 0. 2 integer, so the count gets incremented by 0 because that bit was a 0. Then you do 2 divided by 2, integer division 2. So that's going to be 1. Then you go here, 1 mod 2 is 1, so your count gets incremented by 1, so the count is now 1. You divide 1 by 2 in integers, that's 0. N is no longer greater than 0, so you return your overall count, which was 1. So that's the easy way to do it, if you just want to count the bits. I wanted to do something far more complicated, apparently. Anyway, let's submit it and actually make sure I'm correct. No. Maximum recursion depth exceeded. Oh, you stinky. Is this how you do this? Or is it set max recursion depth? If n is equal to 0, return 0. Just realized I hadn't handled that case. I don't want to break this. This is nice. This is a nice little recursion. It's just unfortunately it requires us to dig n layers in recursion, and Python really doesn't like that. How do I do that? Just a second, quick Googling. How do I see the case that killed me? I don't know if I can, so let's set is it 10 to the 5? That's one with bugger, I need to set that one layer higher. You know what? I can import math as well, because I don't actually need to generate all the way up to that. I only need to go to the log. +1. Maximum recursion depth exceeded in comparison. But I set the recursion limit to be huge. Memory limit exceeded. Ha! I make an absolute pig's ear of this. 10 to the 5. It shouldn't run more than... Well, hang on. 10 to the 5, log 2. Right. 10 to the 3 is roughly 2 to the 10. This should be small. This shouldn't be more than like 30. How is this digging so deep? Well, let's just not do that to begin with. Let's fail the case. This is an easy one, and I'm completely butchering it. Yeah, it should only be 17 layers deep. How is this... Whoa, it's digging really deep. Why is it digging so deep? What have I got wrong here? Let's kill this test case for a second. I don't quite understand. Wait. Now which test is failing? Oh, I'm so confused. This was working a second ago and I've broken it somehow. What is going on? Hang on. Let's just kill it if it reaches a 0. I think somehow that's breaking. But no, that can't be right. Oh, I know what it is. Oops. This isn't an integer. Let's keep that for a second. Python's type system. No bueno. There we go. That's better. Right, I no longer need to print D or even have a depth counter as I go through. So this runs in the order n time in basically a single pass, I think. Yeah, I think this is a single pass. It's a bit of a weird single pass, but it is a single pass. Yeah, there we go. Memory usage was terrible, but that's because we're using a generator which is a little bit slow and memory inefficient. If I was smart enough to work out the way to compute these directly rather than doing this recursively, that would be nicer. But I'm not quite sure how to do it directly. I have just seen the recursive solution. Anyway, that is going to be it from me. I'm sure I'll be back soon. Do remember to like, comment, subscribe, all of that good stuff, and I will see you next time. Bye.